All right, we're going to pick up where we left off yesterday with indefinite integrals, and you're going to see where this starts to merge with the stuff that we dealt with when we were doing definite integrals. So here we do have an indefinite integral of this function, x cubed minus 6x, but then it's specified that we need to evaluate that integral over this interval. So let's calculate this, or write this as an indefinite integral and then evaluate it over the given interval. So obviously we've got a reverse power rule here with that first term. So this is going to end up equaling x to the fourth over 4. And that's just that first term minus. And then this is going to be x squared over 2. Don't forget there's a 6 there. So I'm going to rewrite this as x to the fourth over 4 minus 3x squared plus c, right? Because it's an indefinite integral. But since it's being evaluated over this interval from 0 to 3, now we're asking for a definite integral. And so at that point, we can assume that c is anything. I'm going to assume that c is 0. So what I'm going to do is evaluate x to the fourth over 4 minus 3x squared plus 0 over the interval from 3 to 0. So I'm going to evaluate that antiderivative at 3, evaluate that antiderivative at 0, and then subtract those two results. Okay, so this is going to end up being 3 to the fourth over 4 minus 3 times 3 squared. And that's the first term of this subtraction problem. And then 0 to the fourth over 4 minus 3 times 0 squared. So obviously that second term is all going to be 0, but the first term ends up being 81 fourths minus 27 minus 0 minus 0. So that all can be negated there. And if I want to turn this into a decimal or a fraction, I could do that. I'm just going to leave this as negative 6.75. So this is just an example where this is really a definite integral, but it's disguised as an indefinite integral. So it's just another way that I could have written this, right? Those two things would have been the exact same thing. But now we know that we can evaluate indefinite integrals and then deal with the interval. All right, our second example, looking a little bit more complicated. This is a definite integral, but we're going to start dealing with some more complex functions here. So then we're going to have to interpret the result of this integral in terms of areas. So the first thing I'm going to do is take the antiderivative of each of these individual terms. So that first term is a reverse power rule. The second term here is also a reverse power rule. This is a function that we should recognize as being, and I would rewrite this as 3 times 1 over x squared plus 1. And if I were to take the integral of that function, I could take that constant out. And this is a function here that we should know the antiderivative of. So when I do this, my first term is going to end up being 2x to the fourth over 4. My second term is 6x squared over 2, and then plus 3 times. And the antiderivative of 1 over x squared plus 1 is going to be inverse tangent. And so I'm going to evaluate this at 2 and evaluate this at 0 and then subtract. So I'm just going to write out what this looks like once I've plugged in those values. So I've plugged in my 2 and I've plugged in my 0. I'm going to simplify each of these expressions. So 1/2 of 2 to the fourth is 8 minus 12 plus, I'm just going to leave this as 3 times inverse tangent of 2 because this is not going to be a nice number, minus, and then each of these expressions we've got a 0, minus 0, and 3 times inverse tangent of 0 would also be 0, or negative minus 0. So I end up with none of these terms mattering here at all. And this ends up being approximately negative 0.67855, using a calculator to evaluate that at this point. And so to interpret that, we would say that this is the net area under the curve. So obviously there's going to be more area beneath the curve, or beneath the x-axis, than there will be above the x-axis because we got a negative result here. And here's our final example for today. This is going to be a challenging one, but I would again encourage you to try to do this before I do it. and then check your work with me. So the first thing that I'm going to do, because we really don't have a way of using a quotient rule with integrals, so I don't want to deal with this big division problem, I'm just going to rewrite this as, and it is a definite integral from 1 to 9 of 2t squared over t squared plus, and this is a tactic we've used a lot in the past, all right, so sort of splitting up that fraction into 3 fractions that I can deal with individually, and they're going to end up looking a little bit nicer now. So I'll have the integral from 1 to 9 of, and this is just going to be 2, plus the square root of t minus 1 over t squared. Nothing I can do about that final term there. And so now I'm going to use some of those power rules and things of that nature. So the antiderivative of 2 is 2t, and because this is a definite integral, I don't need to worry about that, any c that's going to come after this. So 2t plus, and if I think about this square root of t as t to the 1/2, then I'm really just using a power rule here, reversing the power rule, so it's t to the 3/2 times 2/3, okay, plus, and the antiderivative of t squared is going to be 1 over t. And just to briefly explain where that came from, I would rather think of this as t to the negative 2. So if I'm taking the antiderivative of t to the negative 2, it's going to end up being t to the negative 1. Now remember, when I take the derivative of t to the negative 1, that's going to equal negative t to the negative 2. So that's why we've switched the sign there from negative to positive. And I'm evaluating this whole thing at 9 and then at 1 and subtracting the results. So this is what that looks like once I've plugged in my 1 and my 9, and all of these terms are going to look a little nicer once I actually evaluate them. So 2 times 9 is 18 plus, and 9 to the 3/2 times 2/3 ends up being 18 as well, plus 1/9, all right, minus 2, and I'm just going to distribute that negative to each of these terms, minus 2/3 and minus 1. And so I'm going to use a calculator now just to simplify this really quickly, and I'll write it as a fraction. 1/28 ninths ends up being the area under this curve between 1 and 9.